Okay, we have this problem of an atwoods machine, and we have fixed pulley around it, a rope, and the rope is freely sliding through the pulley without its rotating, and one end is connected to 100 kilogram mass, and the other end is connected to a mass which is unknown. And initially the 100 kilogram mass is above the ground at the height of, let's say, 1 meters, and the system is released. When the system is released from rest, the 100 kilogram mass hits to the ground in, let's say, 2 seconds. Okay, and the problem is, in that case, what is this smaller mass, or mass m, in order to this motion to happen? So let's denote this height as 1 meter. Alright, since the system starts from rest and the system goes a distance of h 1 meters on 2 seconds, it's obvious that this system is accelerating with a constant acceleration, because all the forces acting on the two blocks are not changing. The only forces acting on these two blocks are the tension in the string and their masses. So since during the motion the tension does not change and also the weight of the masses do not change, the whatever the forces are constant during the motion. If you have a constant force and we have a motion, then this kind of motion will be definitely constant accelerated motion. So if that's a constant accelerated motion, then h obeys this equation, 1/2 at square, from the motion in one dimension with a constant acceleration that we already discussed earlier with a lot of problems. So from this, it is very easy to solve for the acceleration. It is 2h divided by t square, and 2h is 2 meters, and t square is 4 seconds, and so we have the acceleration as 0.5 meter per second square. So this is the acceleration on the system. Well, the problem is, well, what is the mass? Well, if the problem involves a mass acceleration, then it will definitely involve a force, and it will definitely be solved by the Newton's second law. But to apply the Newton's second law, we have to show all the forces acting on all masses. And let's start with the small mass, the free body diagram of the small mass m. And of course, when the 100 kilogram mass is going down, the small masses will go up. And let's take the y direction as upward, and the small mass m will be pulled by tension in the string, but in the opposite direction there will be weight of the small mass mg, and there are no any other forces acting on it. So if you write down all the forces in the y direction acting on mass m, and this will be m times a, and let's write f. Since t is upward, it's positive, and mg is downward, mg will be taken as minus, and this will be equal to m times a. So we don't know what t is, and we don't know what m is, so we have two unknowns, obviously. But let's call this the first equation. If you draw the free body diagram of the second mass, 100 kilogram mass, and we have 100 kilogram mass, and the tension is upward and its weight is pulling him downward, but we know the mass, it's 100 g, it's the weight. And let's write down the Newton's second law in the y direction for 100 kilogram mass. And since it's going down with this choice of coordinate, which is y upward, it will be minus 100 a. Okay, a you already calculated in the previous part. So let's write down the forces then. T is up, T minus 100 g. and this is equal to minus 100a. So from this equation we can solve for t. T is equal to 100 g minus a, and in the first equation we can replace t by this value 100 g minus a, and this is and on the other side we can pass a minus mg to the right hand side. So in that case we have m times g plus a, and if you solve for m you will see that 100 times g minus a divided by g plus a, and let me bring this here. M is equal to 100 times g is 9.81 minus a is 0.5, and 9.81 plus 0.5. If you do this in your calculator, let me do it quickly. Alright, it is here 9.8 minus 0.5, 9.8 plus 0.5, 0.90, and if you multiply this by 100, it is of course 90 kilogram. Oh, it is almost 90 kilograms. Okay, so well, it's right, m is smaller than 100 kilogram because of course the motion, you can simply understand this because 100 kilogram mass is going down, so m should be of course less than 100. Alright, so this is one example solved by applying Newton's second law, and this system is known as atwoods machine, and that's it.